Hello students, welcome to today's class on algebraic identities. In polynomials chapter especially we discussed what is a polynomial, how to find the remainder when we are dividing with another polynomial, remainder theorem, how to find the factors using factor theorem. So, we have discussed a lot many things, right? And in the same continuation we are going to learn few identities. What is the meaning of identity? Some kind of formulas or some kind of relations which are true always for any given numbers, right? So, let us start today's class. Before that, let me tell you about myself. My name is Avinash and I have done my graduation from IIT Kharagpur. So, what we discussed in the previous classes, you can see here, we discussed what is division of polynomials, dividing this polynomial by x minus 1, right? And we also obtain the remainder, and that remainder we can directly obtain if it is x minus a, simply this is p of x. So, p of a will give you the remainder. P of a will give you the remainder. This is nothing but remainder theorem, if you can remember that, right? And we also discussed factor theorem, right? And we also discussed, so once again remainder theorem, the same thing I am saying, the remainder is p of a. The remainder is p of a. And in the same way, we also discussed factor theorem, and the continuation for remainder theorem, whenever that remainder became 0, exactly 0, then the given number is a factor, or the given function or the expression is a factor of given polynomial, right? Same thing in 2 points. If p of a is equal to 0, that means the remainder itself becomes 0, we can say that x minus a is a factor. And if we can say if x minus a is a factor, definitely p of a is equal to 0. From both the cases it will be true. That is what factor theorem states that, okay. And in the last class I gave you this question and we stopped it there, right? And I told you to try that, but once again let me help you with the answer, how to factorize this one, and then we can go ahead for the next question. So, x cube minus 23x square plus 142x minus 120. First thing what we need to do for every time, everywhere, any type of any degree polynomial, you need to find the factors for the constant, that is minus 120. Minus 120, okay. So let us say we are having plus 120. We'll take care of the negative later. Let us try to write the factors for 120. What we can write? 12 into 10 or 10 into 12 with positive, negative, whatever it is. And let us come from small numbers. Okay, so 2 into 60. All the 120 into 1, okay, I think this is fine. I will be writing the first one as 120. Let me erase this. Even 1 and 120 will be the factors of 120, okay. So, 1 and 120, I am not taking about negative into consideration, we will talk that about later. 260 and 3 times 40, 4 into 30, and what else? 5, I think 5 into 24, 5 into 24. Right, and 6 into 20, 6 into 20, 7, no, 8, I think 8 into 15, 8 into 15, once again carefully check that, 15 8s, yes, 15 8s is 120, and 9, I don't think with 9 that will be cancelled, 10, so 10 will be 12, 10 will be 12, and all the reverse will come, 12 into 10, 15 into 8, 20 into 6, so all these ways are the factors of given number 120. So, out of these people, in these type of questions, we need to definitely one of them will be the answer. One of them will be a factor, right? So, let us try to verify with one of the value. Let us take the smaller value 1. Let us substitute 1 and let us say if we can find whether 1 is a factor or 1 is a solution, okay. So, if you keep 1 here, what happens? 1 cube is 1 minus 23 into 1 plus 142 into 1 minus 120. So, 142 plus 1 will give you 143 minus 120 into 23 will give you 143. 143 minus 143 will give you 0. Yes, exactly correct. Okay, we can say that when I substituted x equal to 1, I got 0. That means 1 is one of the solution of this equation. 1 x equal to 1 is one of the solution. It is a cubic x cube. It is called cubic equation which will have 3 roots. So now our aim is to find the remaining 2 roots. What is the first root? the first root is x equal to 1, we need to find the remaining two roots, correct? Okay, we need to find the remaining two roots. How to do? So as I know x equal to 1 solution by using factor theorem. By using factor theorem, I can say that x minus 1 is a factor of the given polynomial. X minus 1 is a factor of the given polynomial. So now, if x minus 1 is a factor, can I divide the given polynomial with x minus 1? Let us verify that. X minus 1, let us try to divide x cube minus 23x square plus 142x minus 120, so that we get the other quotient from where we can get other two roots. We can get the quotient from where we can get the other two roots, correct? So I told you, if you can remember the procedure, x cube divided by x. Okay, I'll use this space. X cube divided by x will give me x square. So write x square here. Let me erase this part. This is not required as of now. Okay, so I am just erasing this one. Right. So x cube minus 23x square plus 142x minus 120. What we can say, if we have x square here, so x into x square will become x cube, minus 1 into x square becomes minus x square, correct? So cancelling these two. So subtracting x cube minus x cube is cancelled, minus 23 plus x square, we are subtracting, plus x square minus 22x square. People who didn't listen the previous class of division, please try to see that video, or else you will not understand what we are doing here. Now once again, minus 22 and this is x, minus 22 x square by x, minus 22 x square by x will give you minus 22x. So we will write here minus 22x. So multiply, let us try to bring this one, plus 142x. Okay, minus 22x square plus 22x. So can we subtract these two? These two gets cancelled. 142 minus 22 becomes 120 into x, 120x and minus 120. 120x minus 120, correct? So plus 120 divided by 120x divided by x, that will give you 120, plus 120 will give you 120x minus 120, yes. So this is exactly correct. So we will get the other two roots from the quotient. Okay, now this is actually equal to x minus 1 into x square minus 22x plus 120, the same value, correct? X square minus 22x plus 120. So now it is your duty to factorize this one. As we have discussed how to factorize quadratic. Okay, so write the factors such that the sum should be equal to minus 1, right? So I am not doing that, I am leaving it for you to get the other two roots so that you can find the remaining x values. So this is how you solve. So now your question is, sir, how to know the very first root? The very first root, here we substitute x equal to 1. How to know that? That is a trail method, people. You need to substitute one or the other value to get it. Okay, there is no other method to find the first one, at least until the present in your school level classes. We will be learning the actual methods later. But initially, whatever the questions you will get, definitely 1 or minus 1, 2 or minus 2, 0, 3 or minus 6, some small numbers will definitely be a factor of that, right? So let us move forward and let us see what else we can learn today, right? So let's come to today's topic, that is algebraic identities.